Okay, so the next thing that I want to do is I want to do the variable for my exposure. And it's the years of smoking. So this one's going to require a few different variables to put together. So let's remember what they are. So the first one is SMQ020. Have you smoked at least 100 cigarettes in your lifetime? And if someone has not smoked 100 cigarettes at least, then I'm just going to consider that they were never a regular smoker. So they're going to get a code of 0 years of regular smoking. And then I also have a variable which is SMD030 for those who are smokers. So the age at which you started smoking cigarettes regularly. So this will be the starting point for counting the time of regular smoking. And then I will ask them, do you now smoke cigarettes? And they have like every day, some days. So probably I will consider either of these as someone who currently smokes cigarettes. And so their time of regular smoking is going to be from when they started, the age they started, to their current age. If they don't smoke cigarettes now, but they did before, then what I'll do is I'll look at this variable, the age that they last smoked cigarettes regularly, and calculate how many years they smoked from their starting age to the age when they quit. Now, what we'll see here is we see that there are some variables here that we need to, or some values that we need to recode to missing probably. So if somebody refused or they didn't know if they had smoked 100 cigs in their lifetime, I'll probably just count this as missing data. Same thing here, the age they started, 777 or 999. So I think what I'm going to do is I'm going to start with getting these 4 variables ready by getting rid of these refused and don't knows. So let me go ahead and start that. So this is years of smoking. So I'm going to say data, work data, set, work data. And what I'm going to do is I'm going to just recode those things to missing. So let me just do them one by one. So the first one is smoked at least 100 cigarettes in your lifetime. So this one, if it's a 7 or a 9, should be recoded. So I can say if this variable is in 7 or 9, then that variable equals missing. Okay. And the next variable is the age started smoking regularly. Now the values I want to recode to missing are 777 or 999. If that variable is in 777 or 999, then that variable equals missing. Now the next one is SMQ040. This is a 7 or a 9. So if this one is in 7 or 9, then that variable equals missing. And the final one is SMD055. And this one is 777 or 999. So if this variable is in 777 or 999, then that variable is equal to missing. So that will recode all of those to missing. And so why don't I just take a look at their values? And I can just say the first one is SMQ020, SMD030, SMQ040, and SMD055. All right, let's run this and see what we get. Okay, oh, these are ages, so I shouldn't be using a proc frequency for ages. So which one's SMD? The SMD ones are actually continuous variables, so I should be using a proc means. And the SMD, let me take this one out of here. All right, let's try this again. Okay, so what have I got here? So I've got basically SMQ, I've got 2 levels. Is that right? Yeah, yes and no, 1 and 2. And then for this one, SMQ040, I should have 1, 2, and 3. Let's see what I've got. Yep, there it is, 1, 2, and 3. And then these ones, these go from the 030 goes from 0 to 72. What is 030? Age, started smoking cigarettes. Oh, zeros are never did. So how should I use that? I think actually in the logic when I create the variable, I'll be able to distinguish those. So that's probably okay at this point. And then SMD055 goes from 3 to 78, the age where you last smoked cigarettes. Regular 3 seems a little bit young to be smoking. Let's see what that is. Age last smoked. Number goes from 10 to 78. It looks like there's a mistake in this. So this has got a 3 in it. So I'm going to do a proc univariate on that one just to see what the bottom values are. Proc univariate variable. Which one was it? It was the 055, SMD 055. Let's see what proc univariate shows us. So one of the things that proc univariate does is it gives you the five lowest values and the 5 highest values. So I can see that the lowest value in the data set is 3, and then the next one is 10. So this 3 is an error. There shouldn't be any 3s because it tells us in here that the number only goes between 10 and 78. So here's an example where this is actually cleaning the data. There's a mistake in the data that we found. And so what we want to do is we want to actually take that data point out. So what I'm going to do is I'm going to put another one in here. I'm going to say if SMD055 equals 3, then SMD055 equals dot. So that'll take it out. So then probably what we'll see is then the proc means looks correct. Let's see what it looks like. Yeah, now it's going from 10 to 78. So I think our variables are okay. And so we've cleaned those. Now what we have to do is we have to construct the variable itself. And so I'm going to take these out here. I'm going to save because I haven't done that for a while. And so what do I want to do here? I want to create a variable that has, it's a continuous variable that has a number of years that somebody smoked. I'm probably just going to call it smoked _ years. And so what I can do is I can say that I know which people have smoked for 0 years. So one of them is the ones who say that they never smoked more than 100 cigarettes in their lifetime. So if SMQ020 equals 2, those individuals have smoked for 0 years regularly. So I'm going to go ahead and build that first. I'm going to say if SMQ020 equals 2, then smoked years equals 0. So all those people who were coded 2 for this variable are going to now have smoked years of equal to 0. Okay, so these are the individuals who never smoked. Now we have individuals who did smoke at least 100 cigarettes in their lifetime. These are SMQ020 equals 1. And so the next thing that I want to do is I want to work only with those individuals who answered that they smoked at least 100 cigarettes in their lifetime. So what I'm going to do here is I'm actually going to embed an if-then statement within an if-then statement. And so usually the structure here is that we say if this is true, then do this. and we put something here without any semicolon. But because I'm going to embed another if statement in here, what I'm going to do is I'm going to put a semicolon. And then I'm going to go down here and I'm going to indent just to make it easier to read. And what I can do then is I can do another if-then statement in here. And this if-then statement will only be considered if this is true. So its first is like, if this is true, then go down to this if-then statement and do what it says to do. So what I want to do is, these are the people who have said that they smoked at least 100 cigarettes in their lifetime. And there's going to be two calculations. One calculation for people who currently smoke cigarettes and one calculation for people who don't. And so let's start with the people who currently smoke cigarettes. And so I'm going to say that if they smoke every day or some days, that they are current smokers. So let's start with that. If SMQ040 is either 1 or 2, so as SMQ040 is 040, right? SMQ040, yes, that's right, is in 1 or 2, then I'm going to calculate the smoked years by, these are people who are currently smoking. So basically the number of years they smoked is their current age divided, or subtracting away the age when they started smoking. So what I want to do here then is I want to use the current age, and so the current age in years is going to be, I have a variable for the current age in months. What is the variable? There is age in months at exam. So this is the variable for the current age in months. So if I take the age in months and divide it by 12, that will give me the age in years. So that's the current age. And if I subtract away the age when they started smoking, then that will give me the number of years that they smoked. So what is the variable for the number of years, or the age they started smoking cigarettes regularly? It's this one here, SMD030. And so if I subtract that away, this should give me the value for the number of years that they've smoked. This is for people who are still currently smoking. Now, what I want to do then here is I'm going to introduce a new concept, which is the else statement. And so this is an if, then else. What it means is, if this is true, then do this. Otherwise, do this. So what I want to do here then is I want to check if SMQ040 is equal to 3. Now, if SMQ040 is equal to 3, that means that they don't smoke cigarettes now. They used to, right? I know that they used to smoke cigarettes because I've limited it to individuals who are SMQ020 equals 1. This means that they smoked at least 100 cigarettes, right? So these people now don't smoke. So what I want to do is I want to take the age when they last smoked cigarettes regularly and subtract that away from, and subtract away the age when they started smoking. So then what I can say is, that's the age when they last smoked cigarettes regularly minus the age when they started smoking cigarettes regularly, which is this one. So this should calculate the years of smoking correctly. Let's run it and see what happens. Actually, I should probably save this in case it crashes. Looks like I have an error somewhere. Oh, I forgot to put an if statement in there. This has to be else if. Let's try this, see if this works. Okay, that seems to have run okay. Now notice this note here. It says missing values were generated as a result of performing an operation on missing values. So for some people, I'm not able to calculate these years of smoking because they have missing data on one or more of the variables. So it looks like I've lost maybe 7 people here, and I've lost 256 people here, so not too many. But I am losing some individuals because I have missing data on some of the variables. So let's look at let's look at the distribution of the individuals the number of years that people have smoked. All right, let's see what this looks like. Okay, so we've got a lot of people who didn't smoke at all. And then we've got, a pretty even distribution of individuals who have smoked from, more than 0 years all the way up to 65 years, a few people. So here we have a continuous variable. Now, this might look similar to what we had before, and you might think that I would want to use a categorical variable for this. You could cut this up in a categorical variable, but this is actually good information. And this is also good information. That's different than what we saw before when the family income to poverty ratio variable above 5 was coded to 5. These are actually zeros. So these individuals are actually zeros, a quantitative number, not a category. And we just have a lot of more people in this category. These are the non-smokers, the never smokers in the data set. So that is okay. It's okay in a continuous variable to have more people in one part of the distribution than another. That won't hurt our model at all. So I'm just going to keep this as it is. So now I have the smoked years variable completed. And let me just save this. Okay. All right, let's take a closer look at this code because this is a somewhat complex code. And so what can I say here? So let's first look at the basic structure of if-then statements. We've already seen that, an if-then statement has some is if, and then some statement, we check it to see if it's true. If it is true, then we do something else. And before we've just had some statement, we would recode a variable or something here. Now there's a way we can expand this that we haven't done before. We can say else do something. So this part is something to do. So this is an if then else statement. So if this is true, then do this. Otherwise, if this isn't true, do this. So this is a basic if then else. And I'm using this structure here within these 2 lines of code. But the reason it's more complex is because inside this do statement, I'm actually embedding another if statement. So this last line of code right here, or the third or the fourth line of code here, is the structure is else, and there's something that is supposed to do under the else condition. But what I've done is I've put another if statement in here. So if this is true, this is SMQ04 equals 3, then do this. So there's an if-then statement embedded within the do part of this up here. So you can layer these like that. That's why this one is more complex. And so here we have if something is true, then do something. Otherwise, do this. But the other thing it's supposed to do has an if-thing statement. So if this is true, then do this. If this is not true, it doesn't do anything. So this is basically the structure. And then the other part is I've limited all of this stuff in this line here. I've limited everything to the condition where this one is true. So this is just like this one up here, except that because I have, instead of a simple do statement, I have another if-then statement inside, I have to use a semicolon here. So this is a structure. If this is true, then do all of this stuff. And all of this stuff is, first check if this is true, and then do this. Otherwise, check if this is true, and if it is true, then do this. That's the structure of this if-then-else statement. Okay, the next variable I want to do is age. So let me put a comment in here. And so data, work data, set work data. Now, age, the variable is this one the age in months at exam? This is the variable that I'm going to be using. And so I'm going to, it's a continuous variable. I'm going to first look at the distribution. Make sure everything is okay. And so this is the age in months. It's going between 240 and 930 plus. The age distribution is fairly evenly distributed. That looks okay. But this problem is that this is a little bit hard to understand. I'm not familiar with age in months. So I don't know if the age range is reasonable. So I'm going to create a new variable called age. And I'm going to take it as I'm going to convert this to age in years. So I'm just going to divide by the number of months in a year. And then what I can do is I can get a histogram of the age in months. Let's see what this looks like. So it's going from 20 to about 80, which is what I know the NHANES is doing. So this looks good, actually. So these are good data. There's no reason to recode these. So I'm just going to use age. I'm going to use this variable that I've recoded as my value for age. So age is already done. And I'll comment this stuff out so you can see it. So the next variable that I'm going to do is my outcome variable, my continuous one, the FEV1 to FVC ratio. So let's look at the data that I have for it. And I'm going to use the first spirometry test as the FEV1 to FVC ratio for the individual, because the second spirometry test was only done for those individuals who had a poor first test, and the second test was done with a bronchodilator. So that was to distinguish between COPD and asthma. So the first one is what I'm going to use, and I'm going to calculate it from its baseline, the FEV1 to FVC. I'm just going to calculate it, the ratio. But what I want to look at is they have this variable here for both FEV1 and FVC that indicates the quality of the spirometry test. And so I'm only going to use those that they identified as meeting the standard or exceeding the standard, so A and B. So what I want to do is I want to first, if somebody has spirometry values, but their spirometry, the quality of their spirometry test was, only potentially usable, questionable, or not valid, I'm going to recode their values for FEV1 and FVC to missing values. So let me go ahead and do that. So the variable, let's start with the FVC. This is the FVC value. And what I want is, if the value is C, D, or F, I want to recode the baseline FVC value to missing. So let's go ahead and do that. So the first thing I'm going to do is data, work data, set work data. And let's go ahead and do a quick proc frequency just to see the values in here, just to make sure there's not something odd going on. So A, B, C, D, and F. So there they are. So what I can do is I can use an if statement. If this variable is, now this is not a number. This is a categorical or I'm sorry, as a character. It's using letters here. And so we have to use, when we're indicating the variables that, or the values of the variable that we want to be checked inside this parenthesis, we have to use quotes. So it's C, D, or F. So if this spirometry value is C, D, or F, which means it was a poor quality spirometry test, then I want to recode the baseline FVC value to missing. Now let's get the variable for the baseline FVC value. Where is it? Here it is right here. So we copy that. I'm just going to set that to missing. Now I'm going to do the same thing for the FEV1 values. So if the FEV1 quality, this is the FEV1 quality variable, has the same codes, but what I should do is I should do a quick check beforehand just to make sure it's coded correctly. There aren't any mistakes. So let me just run this line. Okay, A, B, C, D, F, that's all correct. So basically what I can do is I can say if this variable, then this is going to be the same. If the FEV1 value is poor, then we're going to recode the FEV1, the baseline FEV1 to missing. There's the baseline FEV1. So by coding it to missing, I will ensure that I'm not going to use that data. Okay, so now all of the FEV1 to FVC values that I have are of good quality. And so then what I can do is I can just calculate the baseline, or the FEV1 to FVC ratio using those data that I have. So I'm just going to create a variable called FEV1 underscore FVC. This is going to be the FEV1 to FVC ratio, my continuous outcome. And it's just going to be the value of this divided by the value of this. And let's do proc univariate on this new variable. And then let's see how it looks. Something happened. Uh-oh, I made a mistake somewhere. What did I do wrong? The variable isn't there. It says the function. I must have something wrong. Oh, I forgot the word in. I forgot to put the word in there. Okay, so let's do it again. This should be in. Okay, there it goes. Let's try that. Yep, there it goes. And so I have, looks like my FEV1 to FVC ratios go from 25% all the way up to 99%. And I can do a histogram. Let's do a histogram, see what it looks like. Oh, look at that. So it's kind of it's normalish, but it's got a long tail. So we've got people going down into the lower FEV1 to FVC ratio. These are the individuals with worse lung function. So it's interesting. You can see on a population level, the FEV1 to FVC ratio has this kind of normalish distribution, but with a long tail on the left-hand side. It's quite interesting. Okay, so it looks like that's going to be okay. I'm going to comment all of this stuff out. These things we actually did at the beginning, so maybe I will put them up here for your reference. But I'm going to comment them out. Now notice these turned red because I've got a procedure and then I'm using if statements. So I couldn't run the code in this way. But I'm just going to comment these out so you can see them. Okay. And so FEV1 to FVC ratio is there. Let me save it.